This lesson comes out of section 2.4, the product rule. In some of the last sections we learned some very straightforward derivative rules. For example, the sum rule says that if you have two functions being added together and you want to take the derivative, you just take the derivative of the first and add it to the derivative of the second. So for example, if I have y equals x cubed plus x squared, the derivative of that is 3x squared plus 2x. Just do them separately, add them. Same true for the difference rule, said that if you had f minus g and you want the derivative, you just do the derivative of the first minus the derivative of the second. So if I had y equals x to the 1/2 minus x to the 7, the derivative of that is going to be 1/2 x to the negative 1/2 minus 7x to the 6th. Do each of the derivative separately and subtract them. We even saw that for a constant, like if I have g of x equals a constant times f of x, when I go to take the derivative of g, I just have the constant times the derivative of f, meaning that if I have like y equals 7x to the 10, the derivative of that is 70x to the 9. 10 times x to the 9 times 7. It's tempting to, when you have a product, if you have f times g, and you want to take the derivative, it's tempting to think you're going to be able to just take the derivative of the first times the second. But let's try that. Let's say, for example, we had y equals x cubed times x squared. Now realistically we wouldn't use the product rule for this because we would just go about it by expanding that first. But if we try to take the derivative the incorrect way by saying, okay, dy by dx, the derivative is going to be the derivative of the first times the derivative of the second. So multiply that out, I get 6x cubed. Now is that true? Well, this is x to the 5. I know that the derivative of x to the 5 should be 5x to the 4. Clearly those two aren't the same, and it turns out it's this one that's wrong. 5x to the 4 is the correct derivative, but it turns out you can't just take the derivative of the first function multiplied by the derivative of the second function. What we have is called the product rule. And the product rule, again, because of all of our different notations, can be written in a few different ways, but basically says if you do have f times g and you're taking the derivative, you say f times the derivative of g plus the derivative of f times g. Another way of saying that for this one above, which again for the one above you wouldn't really use it, but if I did say I have y equals x cubed times x squared and I want to find y prime, I can say, okay, it's the first function without doing anything to it times the derivative of the second plus the derivative of the first function times the second without doing anything to it. And if you simplify that a little bit, you get 2x to the 4 plus 3x to the 4, which equals 5x to the 4, which does agree with the much simpler version that we did up above. So at least we can see that this product rule does work. As far as proving it, you can find a proof of this on page 90 of your textbook. It's a bit of a yikes. You can do it with limits, obviously, and come up with it, but it's it confuses a lot of people. It's not something I'm going to require you to do on your test. But so let's go forward using this product rule and see what happens.